Welcome everybody. My name is Luke Zorowski, and today I'm going to show you how to prove side-side angle works if we know that both triangles are acute using just our compass straight edge tool. So side-side angle, if you're not already familiar, is the concept that for any two triangles, if we know that one angle is congruent between the two of them and that they also have two side lengths that are also congruent, then it must be the same triangle. A key thing to denote about side-side angle is that the angle lies outside of the two side lengths. It is not the angle in between the two sides. Otherwise, that would be known as side angle side, which is always true for all triangles. But side-side angle, as you'll see later on, is not always true, unless we had more information, like if both triangles are acute. So let's get started. First thing we should do, construct an acute triangle. And how do we do that? First step is by constructing a straight line between any 2 points. Call these A and B. And now there's tons of acute angles we could choose from, but we don't want to just pick one at random and have to try to measure. We're trying to construct these. So the way to actually construct these is by, well, creating a perpendicular line, shockingly enough. If we find a perpendicular line here at point A, we can see that there's a whole arc of acute angles that we can choose from. So to make a perpendicular line at A is we got to put our compass tool on point A and find two other points on the line that it inhabits that are equal distance from it. Changing up our length, we'll be making arcs from A and B. We'll be making arcs from these 2 points that we have just created. And we really only need them above and below A because, well, that's where we kind of know the perpendicular line is going to be at. As you can see, we have 2 points here that we have constructed. And there you have it. We have a perpendicular line that goes directly through A. Now again, this is what we needed. We didn't need a perpendicular line. We needed an acute angle because we're not making right triangles. We're making an acute triangle. But what we do know is that our acute angles are going to be in between our 2 lines here. So what we can do next is at point A there, we can construct an arc of all the possible different points that we could, or angles that we could make. So any point that lies on this right here, we can use now. And so, be a little creative. I'm going to pick this one right out here. And we can call this one C. And now we'll draw a straight line from A to C. And actually, I'll draw it through it. And I'll rewrite C over to the side of it. And there we go. We have angle A constructed, and we have confirmed that it is an acute. So angle A is acute. Now we have a new point out here, C, that we can work with. Well, now we got to make sure that angle C is an acute angle. And so we'll do the same process of finding out a perpendicular line that goes through C and then creating an acute angle of our choosing. So there's the 2 points that I'll use to try to find the perpendicular line. Stretch this out and we'll make arcs on both sides. We can kind of guess where we think the perpendicular line is going to go through. Makes a little help. That way you don't have to make full arcs or full circles. And there we go. We got 2 lines. We got 2 new points to use. And we draw a straight line through C that we know is a perpendicular line. So to get our acute angle here at C, we know it's got to be somewhere between our perpendicular line and AC. So let's go ahead and put our compass tool on C. And we're going to make an arc down here. And we know that all these points would be an acute angle. Well, actually, all the ones before that perpendicular line there. And since we can't move AB because we got our angle right here, we have a nice little point right here that we can use as our final angle here. and call this one D. Draw a straight line from C to D. And we know that C is now acute. The last one we don't know about is D. And so to double check, because depending on how we constructed this, we could have constructed two acute angles and accidentally made angle D to be an obtuse one. So to double check that we didn't actually accidentally do that, we do the same process of finding a perpendicular line, making sure that our angle lies in between it. We got 2 points. We'll make some arcs up here. And we'll do it again on our other point. And we can double check that our angle is in fact not right or obtuse by drawing a perpendicular line. And what do you know it? In fact, angle D is also acute. So we just constructed triangle ACD to be acute. But before we continue, it would be helpful if we got rid of a little bit of this noise around here. So now that this triangle is acute, how do we know that there's another triangle that can have two of the same sides and one angle, but not be the same triangle? Let's start by picking which ones we want to keep the same and which ones we could possibly change. I say that, in my opinion, to help me out, would be angle A would be a good one to choose from, to be our one that's the same. And angle AC, we'll leave to be the same, and CD to also be the same. So we're going to see if we can construct a different triangle that has all these same features, but has a different, and what would be different would be our line segment AD. An easy way to show you all the different triangles that can be made from these same segments is, well, our line AD cannot be changed. Our line AC cannot be changed. But our line CD, this angle right here, its location can be changed because its location at C could also be changed. So we're going to measure the point of C to D, and we're going to draw a circle of all the possible points that that line can make. And wouldn't you know it, what we have here is a line going through a circle. Circle C, our line segment CD, is our radius. And it intersects here at D, because that is the distance, but there's another point of intersection right here. We can call that D prime. And if we draw a straight line, well, we have another triangle that actually fits our description because angle A is the same, side length AC is the same, and side length CD prime is also the same. So side-side angle does not always work. But the other feature is that both triangles are acute. And we know ACD is an acute triangle. But if we look a little closer at ACD prime, this looks a little bit obtuse. That's not enough to prove it. But what we can do is look at what happens when we create these triangles. So side-side angle doesn't always work because there is exactly two triangles that can be created. Because when a line goes through a circle, there's exactly 2 points that line intersects at. So there's only going to be 2 triangles we can test for. So we got to prove that ACD prime will not be acute every time we create it. And how we can tell is pretty interesting. D prime CD, this triangle we haven't even discussed about, this little extra area, it's an isosceles triangle. What that means is that angle D prime in it and angle D are congruent to each other. Where this comes into play is that we know our triangles have 180 degrees, and we know that C is acute. But putting that aside, D prime and D, if they're the same, what we know is that these two angles, or each angle itself, cannot be greater than 90 degrees. Because if both angles are 90 degrees, well, then we actually can't create a triangle anymore. And if it's greater than 90 degrees, well, then we definitely can't create a triangle at that point. So we actually know that D prime and D, those angles have to be acute in this triangle. Why does that matter for our other triangle, ACD prime, to prove it's obtuse? Well, you'll notice that our angle D prime, or to be more specific, angle AD prime C, is a linear pair to angle CD prime D. And by a linear pair, that means they're also supplementary, which shows that if this is acute, which means it must be less than 90 degrees, we'll do with angle angle CD prime D. If we know that has to be less than 90 degrees, well, supplementary angles are 180 degrees minus, well, that. And that's how we know what angle AD prime and C are going to be. So because we know that D prime, that angle there, CD prime D, is an acute angle, we know that AD prime C has to be an obtuse angle. And so if we know that both triangles that can be created are acute from SSA, they must be the same triangle, because the only two triangles that can be created using the same side-side angles, one is acute and one is obtuse. What's interesting is that this works also if you're trying to prove that SSA works if both triangles are obtuse. In fact, the other one would have to be acute using the same logic. I want to thank you very much for your time and patience. This was a very fun proof, and I hope you all enjoyed. Have fun making triangles.